Hi everyone, welcome back today. It has been a while. I was so busy with all my, lesson plan and course online upload and s- making PowerPoint presentation. So I opt for a while now. Nice to meet you on my audience here again on YouTube. So I'm so exciting. Also, with the very interesting topic today, I would like to share with you. And this topic, I call the name of the lesson today is second order differential equation equilibrium system. And I have two interesting diagrams going on the board. You might feel curious. Okay, so what is the equilibrium system, right? And I'm going to talk about that. So bear with me with my long talking today. I will have to explain a lot of concept, and I believe that you might be interested into my talking, even though I have accent, because the topic is so fascinating. I hope so. So, what is equilibrium? Now, if you make an observation about the lock, pendulum lock, right? Kind of pendulum lock. In my house, I have a pendulum clock. I assume that in some place you might have it as well, right? And when I was a child, I used to notice about the lock keeping going backward and forward, and nobody push it. I don't know why it keep moving. It never stopped. I used to, as a child, used to sit there and watching the clock, and I just wonder, oh, nobody like pushing it. Why it keep moving and backward and forward for such a long time? Actually, if I have time, watching 24 hours, it's never stop, right? Um, we just watching about 10 minutes or 5 minutes, I guess. So we don't know anything. And I'm not Newton, so I question, but I never can have the answer. Not until now I grow up and I learn about physics, I learn about mathematics, just like you. Now I share my passion to you, and you will share my ideas to other people you know about this topic if you like. Feel free to share. We live in a free world, right? Yeah. So um, why I'm talking about that, because I remember the Newton looking at the atoms falling down to the ground, and he questioned why the atoms not going up. Everybody know about that story if you learn physics, right? And therefore, Newton's from that question of the phenomenon in our universe. For us, we see the atom fall down the ground. We never question it. But he's a scientist, a great scientist. So he questioned, and his curiosity brought to our world a theory, then a proof to prove his theory is correct. And the combination between physics and math. So physics question phenomenon and bring up with the hypothesis, bring up with the um, from the curiosity, get to the question, and the mathematician try to prove that, right? Using on the computation and whatever they can to try to prove the theory is correct. Now, after they prove it, they also have to test it, right? And then it become a law when it get into the um, true. That's the law, right? That's the reality. No one can change. No one can argue. So that become a law. So Newton law. Now today I will talk about second Newton law. And in the second Newton law, we're talking about any force have an equal reaction force. That is the second Newton law. And that apply in this pendulum. So let now I also want to have a little social chat with you today. Forgive me, like it's just like I don't want to take too much time, but at least I give you some interesting ideas, a food for thought. Okay, the Newton law said that any force have an equal reaction force, and we see that like in the roller coaster, right? Everybody, the corner, the scream is rising up when the fall is over. Or another proverb in English, it is always darkest before dawn. It's always darkest before dawn. And it's true. I remember in our Vietnamese language, we say something like sau cơn mưa trời lại sáng. We promise that if the sun went off, our life is dark. We live in a darker time. And I guess in our pandemic situation right now, right? It's sometimes sad, it's very dark. But we promise that after the raining, then the sun will rise. And when the night go in, we sleep in through the darkness. But then we wake up in the morning, it becomes bright and it becomes sunshine again. And that gives us a hope for our future, a hope for a difficult time will be over. So Newton's second law is not just talking about the physical phenomenon in our universe. I found it fascinating when we interpret it in the social. And any force have an equal reaction force. For example, in social talk, let me be talkative a little bit today, right? I found this topic is fascinating. And like if I bump into you on the street and if suddenly I yell at you, let's say, oh, you're a bitch, you are, like you bad person, and you very angry voice. What happened? Any force have equal reaction force. If that, like naturally, you will yell at me and you will, because I attack you and then you attack me back, right? But if I suddenly bump you into you on the street and I say, hi, how are you, nice, smiling. Even if you don't like me, maybe we have some problem before, there's no reason for you to yell at me and attacking me, right? Unless you're truly a very mean person. I mean, so that is applied into phenomenon, social phenomenon as well. Any force have reaction force. And by the Newton's law, any force have reaction force. The fact that I'm standing here, there is a force of gravity pulling my body down. However, there's an equal force pushing my body up, and that force downward and upward is supposed to be equal to keep me balanced standing on the floor. I remember that my physics teacher before, he used to say that if there's no Newton's second law, equal reaction force, I will grasp the floor and I will sink into the earth. And maybe he's so exaggerated. At that time, I was questioning my mind. That's not true. How could I sing it like I mask the floor? I'm not like, I'm so weak. I cannot even mask floor and sing into the earth. But that may be true. He said that if there are no equal reaction force, my body would just keep going down, mask the floor and go sing into the earth. To be honest with you, until now, I still don't know if he's joking or he was right. But anyway, my example to you would be a lot easier to think about it, right? The pendulum. Okay, so let me go back to the topic about the pendulum. And what do I mean by any force have equal reaction force. So if I punch a white ball here, there is a force exert back to my hand with the same magnitude of the force to keep my hand not get into the wall, like my physics teacher said. Okay, so let me explain to you the pendulum. Now this pendulum actually just have one string, and there's the bond here, and the bond of course have a mass, right? Have its own mass. And this force, the bond have a force of gravity pulling it down, and this force is mgh. Now what mgh mean? Mgh is the mass of the bond times with the height and time with the gravity of the earth pulling the bond down, right? Now this height, let's say this vector force here, from here to here, is the height of the bond. So the force here is also depend on how high the bond is as well. And in this case, when the pendulum swing to the left or swing back to the right, this height is exactly the same. This height on the left exactly the same like the height on the right. Now, if I assume that if this pendulum is not stopped right here when it swings to the left, but it go up very high from here to here instead. If I assume, right, this is, let's say this is height 2. If let's say if Newton is not correct, but you know he was correct, right? Let's say if this bond go up in this way, but when it go back down to the right, it's just very low. And when it go back up, it's very high. Actually, this never exists. That's why I cross it here, right? This is just the assumption, my assumption to demonstrate to you that's not true, right? This high level exactly the same like this high level. And the trajectory, this we call the trajectory of the bond go backward and forward is always the same distance. So it means the distance from the middle to the left, the right, D, let's call this D, exactly the same like the distance from the left and call it the same D. And that's why you can see that in phenomenon in our magician, right? The magician try to make a magic and make you believe that sometimes they have to base on the physics law like this, right? And they know that they put the pendulum and they put a big masses on the pendulum, and they prove to you that if they push the bond and you see that you scream, you're afraid that, oh, it's going to hit his face and going to mash his face into the pieces, right? Or at least it bruise, make him bruise. But it never, because he used the law of physics. He knew that the bond never reached his face. And that's why we're so scared when we're watching the magician perform his performance. But everything is about the physics, everything about the law of physics. And it must be true, right? So now we know that at this position, I call this is a equilibrium line, okay? Equilibrium. So this middle line is an equilibrium. And this system of the pendulum is an equilibrium system. It means anything on the left equal on the right-hand side. It's just like an equation, right? And this equilibrium system can be expressed in mathematics is second derivative y prime adding with a constant k times y equals 0. It means this equal this. So y, therefore, if you say this phi adding with minus phi, then of course it equals 0. So this system have to be equal to this one, okay? Now I will talk about that later, but let me go into another equilibrium system here, another diagram, right? You will see that on this is called an oscillating spring, and let's say you exert the force on the spring, you pull it down, right, up to this level. And this force is also mgh, right? You exert the force. Mass times gravity times with the displacement height here is the displacement of the spring up to this level. If you pull it down this level, but when you release the spring, what happens? Is oscillation ring go backward, right? Like my arrow here, go backwards with the same distance as when it's pulled downward, right? It go backward with the initial position. And this is another phenomenon in equilibrium system I would like to talk about today. Now, get into the mathematics. This is physics applied with mathematics, combination, right? You can understand this equilibrium system as another thing. This bond is moving, and the moving, when the motion of object, when it's moving, we call it kinetic energy, right? So the force is some kind of energy, right? So when it moves, we call it kinetic energy, okay? Now this kinetic energy make the bond move to the left and then coming back to the right. But when it come here at this position, it stop. Now when it stop, does it have energy? Yes, it does have energy, even though it's not moving anymore, but we call that energy is the potential energy. And like you have a potential in music, you will do fabulous in music, everything, because you have potential, right? So this energy, when it stops here, it's sitting high there, it becomes potential energy. So the mgh here, you also can call it as the potential energy when it stopped right here. But when it's moving, right, it move down here, move in the middle, this become a kinetic energy. So there is another one we understand in law of physics as well. Energy can never be created nor destroyed. It's only can transform from one form to another. What does that mean? It means if you have a tank here, your energy coming in here and going out of the tank, this is in, this is out, is the same. The amount of energy go in the system and get out the system exactly the same. Energy never can be created nor destroyed. It's only transformed from one form to another. So that is another law in physics, and it's true. And this kinetic energy make the ball moving to the left and moving back to the right. And when it moved to the left, stop. So it transferred this kinetic energy right here back here, become a potential energy. When it stopped, it's sitting right here, the bond sitting right here. But this energy to transform from kinetic energy to potential energy. Then when it swing backward here is the kinetic energy again. And this kinetic energy go back to the right and stop right here. And it's also become another potential energy. So it energy never can be created nor destroyed, but it always the same. It just transforms from the form of kinetic energy to potential energy. So this topic is fascinating. Don't you think so? Because we see physics applied to our real life in our social phenomenon as well as in physical structure of our materials in universe. So I hope that I can persuade you love math like me. Okay. Actually, when I was a child, I'm not so interested in science and math. I feel it more understandable when I grew up, and I love it when I start to learn it in university, because I believe that I want to be a teacher, and I love teaching. It's my passion, and I want to share the knowledge. And also, I feel that I have an accent, and that would stop me from being a teacher in North America. But I was a teacher in my back home, and I love to be teaching. I determined to be a teacher. Now I'm standing right here. I'm a YouTuber, but I am professional, taught to you, right? As the same like a teacher in front of the audience, because that's my passion. I never feel tired of teaching. Um, I feel I have a lot of energy and passion when I teach. And because energy never can be created nor destroyed. It just transfer from one form to the other. Now I prove to you, I just transform from a teacher form to a YouTuber, but my energy never can be created nor destroyed. Wow. Anyway, so this is the equilibrium system as well, right? Energy, you exert a force and it go down and go back with exactly the same distance. Now, let me talk back into the mathematics. We have, therefore, we have a differential equation here, y cry, and what is y cry? Now, force equal m times a. Mass times acceleration. Our acceleration is the force of gravity, pulling everything down towards the earth. Everybody know that. Now, it turned out the acceleration is the rate of change in velocity. And what is the rate of change of the velocity? The rate of change of the velocity is the result of a change in position. So let's say if I have an object like this, it's moving, right? So my position is right here, moving towards the end, or move to the left or move to the right. So my position is changing. Now, when I'm walking and my object is moving, we call it velocity. So it's a change in the position. And the position function is the original function y. And the rate of change of function y gives us the velocity as the v respect to t, vt, we call a function velocity, right? And then that velocity, when you ride a car, you have a velocity, but also a direction. Now, if you're just talking about the magnitude of your speed, we have a scalar quantity in physics. We call it scalar. But if you're talking about your car driving to the north, of your town, or to the south or the east, whatever, include with the direction, we call it velocity, the rate of change, including both the sign, negative, force, positive, depend on the direction, right? Now that is the change in velocity. When you drive fast, you accelerate your car up, or you decelerate your speed, slow down the car. When you see the stop sign, that causes the change of your velocity become an acceleration. And we denote that as the A in this equation. So in our equation, force, this force, potential or kinetic, this force equal the mass times acceleration. And this is a Newton equation. We all accept about that if you learn physics, right? It turned out what is A here? A is acceleration, is second derivative. We call d square s, and s stands for the position function, okay? derivative respect to time, dt. So d square s over dt. And we know that from other previous video, this notation. So but because our motion of the object swing left and right, so it have a negative. So if I move this to the left, actually this is equal, and this should be described as minor force because this is the motion of the opposite force, right? As well as this one, we can express this function of the spring. Downward is positive, negative, and upward is positive. So this force equal negative m times a because we have a opposite force, right? We pull the string down and it exert another, when we release, it go back up. So that is a force equal negative m times a. And this, if we express in the second derivative, this is, if we move it over, it becomes positive. So this force is, we call the second derivative plus k, and y is the function, right? It's function of the position function, ky. And in equilibrium system, if we have a second derivative, add with a constant here, it's like a mass of the object, whatever, right? Time with the position function y here will be equal to 0. So this is, we call this equation is equilibrium system, our equation in an equilibrium system. The same like here I described, right? So this is just like the second derivative, okay, the acceleration. So this one, I can write it like this, d square s over dt, adding with ky equals 0. And I'm going to, and because it's negative, but when we move to the left, it becomes positive, right? So we have something like this. And actually, I already put up here. So I am going to erase this and erase this. We all know about that. And I'm going to erase because I need to have a room for the next step. So this is the same like d square s over dt. Adding with k, or we can call this is like an s of t, right? Y, this is the y function, right? Equals 0. Now, in mathematics, when we transfer in mathematics, because we have to do some calculation, and you can see that the distance here is the opposite. We can apply in the trigonometry function, and there is the angle theta. This string, how high it is, the bond is, how big the force is when it swing up and swing backward, depend on this angle theta, right? So this equation somehow in this pendulum related to the trigonometry. Trigonometry, which is cos, sine, or tangent, right? Or tan. And that's on your calculator, you can see that. So let's interpret it in terms of trigonometry. And in terms of trigonometry, say that the theorem is say that if there is a derivative d square, or let's call it y prime, right? Adding with the ky, the constant, there's some constant k here, ky, and equals 0, then there exists what? There exists a constant of A and B And this constant of A and B give us this y function equal A cos of square root of this kx, of this k, and the x is just the function outside, right? Adding with b side of the angle theta or just k x, and actually square root. So for example, if we have a function y, a differential equation y prime plus 25y, so the k here is 25 equals 0. Then we will have a y function respect to time or respect to angle theta, whatever, okay, equal some kind of constant of a cos of square root of 25 times x, adding with some kind of constant of b square root of 25 of this k of an x function. Now let's simplify it. I'm going to write this. Let's say it is true. It is true. You want to prove this equation, right? Want to prove this? We say if this, then this, right? We want to prove it. So is this true? If y will be equal -2, just some kind of a number, like randomly -2, cos of 5x, now this angle, square root 25 becomes 5, right? And this is the angle, right? 5x. Adding with b 7 of psi, actually, I'm sorry, this should be a psi here, I'm missing it. Psi, okay? It should be b psi of kx, of 25x, okay? Psi of 5x. And this equals 0. Now, as long as we prove left side and right side, when they add this up equals 0, then this statement is true, right? So how do I prove this? I'm going to go backward to prove it, right? Backward, work backward, work backward. Okay, I'm going to work backward. Let's say, assume that this is the true y function. Let me assume this is a true y function, okay? Let's assume this is true. So I am going to take the derivative of this function. So I go backward. So I take derivative, right? I take derivative. So I will say y prime, first derivative function would be -2, times with the derivative cos x is psi x minus psi x. So we minus time with inside derivative 5. Now we did that in the first course, right? We know how to take derivative of any function. So derivative cos, follow the formula, derivative of cos is minus psi. So minus time with inner derivative, remember derivative of composite function. So we take derivative of inside, derivative phi x is phi, and that cos becomes the sine of the angle phi x. Adding with derivative psi is the cos x. So 7 times with phi times with cos of phi x. This is the angle, okay? So this is the first derivative, but we have to do the second because we want to prove this statement is true, right? So we work backward, we say assume that this is true. We do have the assistant of our y function here. Let's work backward and see what happened. So I'm going to take the second derivative, and the second derivative based on the first derivative. So I'm taking derivative of this function again. So that will become positive 10, right? Minus 2 times minus 5, positive 10. And time with phi again, because the derivative of psi is cos, and we take the inner derivative. So it changed from psi to cos of phi x. Adding with, now cos derivative of cos is minus phi, minus psi, so I'm going to change this become minus 35, right? 7 times 5, 35, and cos becomes psi. And actually, I should multiply with the inside derivative of phi as well, and that is psi phi x. So now we simplify the y graph equal 50 cos of phi x minus 175 psi of phi x. Now, if I put back into this equation, do I have left side equal right side? Let's check. And I don't have room, so I am going to have to erase some of them. Now, I don't want to erase this because I want to see, like, you can see that it's true, right? So this should be keep it. So that's how we question is. Okay. So I'm going to keep the statement, is this true? I'm going to check it, right? Okay, so I'm going to put it back here as the y graph function is 50 cos of phi x minus 175 sine of phi x and I'm going to adding with our k. And what is our k? Our k in this question is 25. Remember, because we say k equal 25, that's why we take square root k equal 5, right? So our k is 25. Now we multiply this k with our y function. And what is our y function? This is the function they gave us, right? So 25 times with minus 2 cos of phi x adding with 35, this is the equation, 35 cos of phi x. And we simplify it, this equal 50 cos of phi x minus 175 sine of phi x. Negative times positive become negative, 50 cos of phi x. This time positive is adding with 175 sine of phi x. And when we add them, it equals 0. Because 50 minus 50 gone, right? The whole thing gone. Minus 175 add 175 gone. So this shows us that this is true. And therefore, if this, then as this. And we'll change this to 25. So if we have the differential equation look like this, then we know our y function will look like this. Minus 2 cos of phi x plus 7 sine phi x. And this we call square root of kx. This we call the square root of kx. And this number we call an a. And this number we call a b. So if we have a constant k equal 25, then it's true that there exists another a and b constant like this, minus 2 and plus 7, make this become equilibrium system. Make our differential equation adding with the ky equals 0. And we just prove that. So it's proven. Is true. Because we work backward, right? Remember? And we take the derivative again. We follow the formula, take the derivative, and we add into that to see if this equilibrium system is true. Left side equal right side equals 0. And everything we work based on this assumption. And now we prove this assumption is true, right? So it no longer to be assumption, it's reality, it's true. It's true that this minus 2 is it, the I here is it, and plus 7 here is it. And now angle here is it, right? It causes an equilibrium system. So this is my talk today for our topic. And I like this topic. It's so fascinating. It's so amazing. One more thing before I end our video. I am going to talk about advertisement for my course online. Now, I just want to remind you, if you register into my course, you have access to all of this material, including the next topic. I will give you an exercise, a practice exercise. Let's say I give you some equation like that, and you have to find A and B and something like that, right? And that is the first part of our practice exercise applied to this equilibrium system. The second next is even more interesting, which is the application, how to solve the word problem, to solve problem solving applied using the formula we learned, using the fact of second Newton law. We accept the physics concept, we accept the mathematical equation. Mathematics equation is true. We're going to apply and solve our reality problem in the real life. So that is the second part of this. How exciting it is. Also, I want to make you love math like me. I am a compassionate teacher anyway. I want to let you know that the course online are really valuable. Why? Of course, I'm talking for me, talking for myself. I want to sell my course, right? It's affordable. Firstly, talking about material. Compare with I'm spending 10 hours a day or 7 hours a day and each day to develop a course in 3 months or 2 months and a half. Now, it seems I am a turtle, right? I'm not a fast person. However, the qualification of education we provide to you on YouTube, it's free. But if you buy my course, it's cheap, right? You have the full completion of my videos, 52 videos in the first course, I believe. And you have all the theory, the formula written down to you in a beautiful PowerPoint format, and the explanation of our video lecture. So the course online actually exactly similar to tutoring one-on-one. I remember I used to write my card on a student. And when we were talking about what we're teaching on YouTube, we are an expert on the topic we were talking about, right? We know what we're talking about. And that's why we're standing here and share with you our knowledge. Regardless we are a certified teacher or not. Now, I am a certified teacher in BC for sure. Maybe some professional, it's just from their experts over the time. I used to ride my car to my student house and driving and tutoring one-on-one of my student in front of the parents. And I remember that is a one-on-one lesson. And the company charged it at least $60 an hour or maybe $45 an hour, right? Now the maximum, if it's very expensive, you can have a 2-hour lesson, which it costs you at least $100. 2 hours, at least $100. That is a minimum charge. Plus with the administration, I have to pay for them back, right? So we not earning that much, but anyway, that's the scenario. And 2 hours, $100. Whereas I sell my course to you, just 200, above 200 a little bit, 52 video. All my energy spending here, and that is just that much. And this the similar, except that when I tutoring you one-on-one, I can watch your doing right in front of my eyes and correct right away. But in my course, you register online, you can email me and we can set up the Zoom lesson online if you have a question. But I believe with on the video, I explain very clearly and step by step like this, and you can rewind the video. So it's the same like tutoring one-on-one, face-to-face, and it's so cheap. Education now become very cheap. And how sad I am, because what? We usually value what is expensive, right? You can go to the nail pedicure and do a piece of nail pedicure. Now I'm not compete with those artists, but I just mentioned you still have to pay a set of your pedicure, sometimes 100 a month, or that's the money you spend. Whereas you learn a huge knowledge, and like with the same cost, or maybe less, or maybe more. But I mean, like, if anything we given to you is for free, we don't value it, and it's true. And the reason we have to pay university costs now, I bear the burden cost of the debt of university costs. But there's some point I feel that is the emotion, the motivation for us. Try to achieve to learn what topic we learn. Because if I'm given for free, I can drag the cost for instead of 4 years, might be 10 years, I complete my degree rather than 5 years or 4 years. And I might not even take a look at it because it's given to me. It's the same like parents spoil their children, give them expensive toy cars and every expensive toys and car, luxury house, but they don't appreciate. They just take for granted, oh, because you are my mom, my dad, you got to give me, right? Now I did say that on children like that, but that is a common psychologist in human behavior. Whatever is given free, we don't realize how valuable it is. So the reason I have this little talk to you at the end of my video, because I want to advertise. Of course, I want to advertise for my online course. I want to sell my course to you. And I want to say that this is valuable. This is true, face-to-face, one-on-one tutoring. You have on the practice exercise, you can rewind the video. Now the difference, we went from the textbook between the course online. They are not the same. You have a textbook, you can read it on your own, self-study as well. This is you also sitting in front of e-learning computer as self-study, but it's not because I am sitting you. I'm talking to you right now, face-on-face, one-on-one teaching lesson. In the CD before we go from textbook to CD, there's only the written document. There's no face-to-face explanation like this, right? So the value of the course online, the pandemic create the course online, but that give us some more adding value into our work, our labor. It's like the cell phone invented, like the Steve Jobs, right? Give us the technology, we can have it now. And I appreciate Steve Jobs so much. Anytime I'm standing here and talking to you, I just feel like in the world of our isolation because of the pandemic, at least we still have a way of communication, social, online, internet. This provide you a private tutoring one-on-one lesson. And we should appreciate Steve Jobs. We should appreciate our professional, our teacher, to give us the knowledge as well as the valuable in academic in education, because I do believe education is make a person better. Now, regardless you use or not one time in your life, but you are a knowledgeable person, you know what you're talking about, particular topic. I mean, like any education, music education, arts, painting, or anything. It's not just math, right? But I am a math teacher, so I'm talking about math. I mean, anything we learn in life is valuable. And the course online is valuable because we sell our labor, we sell our knowledge, we sell our um, hard working and passion, and share our ideas to the whole world. So if we don't have Steve Jobs invented cell phone, we don't have all of this technology, science, advanced development to make it better in our society, human communication in society, and education, equality in education, then why we should not appreciate all of this, right? So anyway, I'm not just talking for myself, but I truly appreciate Steve Jobs, and therefore, yes, I want my audience to appreciate me. But anyway, I try to actually I work very hard on my lesson plan, and I would like to bring to you the best education online. The video I recorded, right? And sometime in the classroom, as a teacher, I used to teach in the classroom public as well. If I make a mistake, I didn't realize that. But here, on the video, I record, I watch it, and I see, oh, maybe I shouldn't talk too much about this. Maybe I should shorten my talking in this topic or that. I can have a chance to redo it for better and serve you better. So I just found online course is really valuable to on the student, and a little money you can buy to make your nails more beautiful, or you buy a dress more beautiful to wear. Why don't you learn, pay a little for the course creator, so we can have energy to keep going, because we have to eat to make our living, to make lesson plan like this, right? So why don't we have picked up by our labor, by you guys, everyone, regardless of education, schools or teachers or student or parents. We try to support our course online, course creator, to bring qualification in our education system. And it's for the best. It never harm. It's never whether you buy it and you don't learn. But I assume when you pay money, you buy it regardless cheap or expensive. And that's why I don't want to give the course for free, to be honest with you. Even though if I am millionaire like Bill Gates, I'm not going to just give it to you for free, because anything give it to you for free, I give it on YouTube for free, right? But I hope that YouTube will pay me something. But I mean, like, you cannot have anything free and you value it. You just take it for granted. So if we have a free education university, maybe we never get a degree. No, I'm just joking. But anyway, I know sometimes it helps for people. At some point, free education is exist, and it helps the poor children, poor student, and family we cannot afford it. I used to never have can afford, my family never can afford to pay me a tutor when I was learning. Um, but when I grew up and became an adult, I tutor my student. I earn money, and I realized that our world is just keep changing, and yes, it's always benefit if you have money, right? But anyway, I just tell you that this course online valuable. It exists, it's accessible, it's valuable, and is qualified. I hope so. I hope you like watching my video and you like learning about math. I'm going to end the video today, and sorry for all of my nonsense talking. I hope it's not nonsense anyway. Stay tuned for our next video. It will be more interesting. Application of equilibrium system in physics and in mathematics. Bye for now. See you.